Okay, lecture number 3. So far, we talked about how you can do decide by contract in Java. In the first 15 to 20 minutes maximum, I'm going to conclude and see how we can move from there. Okay. Version number 5 is where we left off from last week. Okay, version number 5. Okay, let me just remind you very quickly so this will be the final version we have to discuss about how you can do decide by contract in Java. Okay. Basically, for version number 5, we talk about if you want to do withdrawal, you want to make sure the supplier, if the clients already satisfy all the precondition, the supplier will also fulfill their duties. And the way to do it is by using postcondition. Okay? And in general, okay, let me just give you a very quick picture. Okay? In general, if you're making a method call or feature call, okay, you have some objects over here, dot, some method over here, in general, right? We talk about client supplier in the context of OOP. Before the method call, it would be the obligation of the clients to make sure when you call this method here, you satisfy all the precondition. That's what we talk about. You can do it using exceptions in Java. So now what's left, finally, is to say if the precondition has been satisfied before the method call, and then we go ahead and execute the body of implementation for M. Upon the termination for M, assuming that M terminates, okay, we want to make sure in the so-called post states, we talk about pre versus post states. So this is post states, and before that is a pre states, right? We'll talk about these two kinds of states, before and after the method call. Somehow we want to make sure the post condition over here will constrain about how the pre-state value and the post-state value for the same attributes are related. That's basically what we're going to do. But for mostly today, I'm just going to talk about some simple example for withdrawal. But the next topic after this will be to see how to write complete and complex post-condition. That'll be what we're going to focus on. But let's get the basic right. Okay. But first of all, you want to understand, before the method call, precondition. After the method call, it will be post-condition. And the way to specify the post-condition will be to relate the values of the attribute in both the pre-state and post-states. For example, what we said last time, the best way you can do in Java is to somehow store temporarily the pre-state value for the attribute before it is modified. For example, you can see over here for withdrawal, right? That's the method we're talking about, withdrawal. Eventually, we want this particular post-condition to be satisfied, okay? So this is the post-condition. The reason that it is called a post-condition is we are checking this particular assertion after everything has been done for the body of implementation at the end. And then this one is saying this get balance over here. So this is getting the current value, like a post-state value. The current value of the balance. That's a post-state value. But now the post-state value, the balance right now has been overwritten from the pre-states. So the only way to refer to it is by referring to this particular old balance, right? So this is to, I say cache, or to store. Cache the pre-state value of balance. So that we can refer to it. So this is exactly how we are referring to it, okay? So this is the pre-state value that we stored previously. And then we simply specify the relation. We are saying that if you try to do withdrawal, it better be that the post-state value for the balance should be equal to the old one minus the amount. Anything that does not satisfy it should be a post-condition violation. Okay, guys, any question about this? It might seem to you, for a simple example like this, things already get a little bit inconvenienced. Number one, you have to create this temporary variable yourself at line number 4. And line number 11, somehow you have to remember which pre-state value you should really refer to, like O balance over here. It would be very nice if you don't have to do things like line number 4 yourself, okay, in order to do post-condition. That's the disadvantage for doing post-condition in Java, because they don't have any built-in mechanism for you to write post-condition, okay? Okay, my only concern would be, are you okay with line number 11 over here? Line number 11, of course, depends on line number 4, in which case you cache the value for the pre-state value for balance, right? Okay. Are we okay? Okay. If you can understand this properly, later on when we talk about postcondition in Eiffel, it's actually doing this implicitly for you. You never have to cache the value yourself. Okay? It will do for you. That's why it's convenient and more appropriate to do the side-by contract in another language. Okay, that's version number 5. Okay, I'm not going to run this because we already did it last time to see how postcondition violation might occur. Okay, I'll leave that to you. Okay. What I will do now is to just review what we have done so far in the Java, and then we'll move on to the language we're going to adopt for this course. Somehow I spent the first 2 classes just to somehow try to justify to you why we chose a language that's different from what you're familiar with, Java, right? And there's a reason for that. And the reason is, if you want to do design rather than implementation, Eiffel is actually a more convenient language for you to really think at the right level, as opposed to exceptions, assertions, or even caching the value for the pre-state yourself, right? Such inconvenience doesn't exist in Eiffel. Okay, let me just summarize very quickly, okay? And then for the slides, it's self-explanatory. You can also refer to them, okay? So this is more like the final version we have for the account, okay? I'm just showing the withdrawal method for you, okay? Let's remember, there are 3 kinds of contracts we talk about right now. We got precondition, and we have postcondition. And we also got class invariance. So these are the 3 kinds of contract we're going to focus on for most of the course. Towards the end of the course, we're also going to talk about something called loop invariance, but we don't need to worry about it now. Okay? For now, precondition, postcondition, class invariant. Let's see how they are encoded in Java. That's really important to review, and then we can move on. Talk about version number 5, which is the final version we have, which encode all 3 contracts. Number 1, for precondition. You can see for every method, if there's any precondition, you have to say things like this. You got to say, what are the error condition, right? So these are the error condition. And as we said before, they are not exactly the surface condition like a precondition. They are the negation of that, okay? So just to remind you, they are the negation of the actual precondition, right? They are negation of each other. Number 1, okay, that's a precondition, which is not too bad, right? You just have to remember to negate to ensure consistency. Okay, what about class invariance? For class invariance, basically you have to make sure upon the termination for your method, you do not bring the object into a state, like an attribute value does not violate any property you will see. For example, for every account, the balance should be strictly larger than 0, right? So you will see, for example, over here, here. This one here. This is the class invariance for the balance should always be strictly larger than 0. So this is the class invariance. And one thing I didn't quite mention, but it's in the slides. It seems like doing this particular class invariance has different disadvantages. What we talked about last Wednesday was you have to repeat this invariant here for multiple places for as many update methods you may have in your class, right, every time. But the problem is, if one day I change my design, I decide to change my class invariance, there will be multiple places I have to change, right? I mentioned briefly something called single choice principle last time. You can review it, okay? That's disadvantage number 1. Disadvantage number 2. Contracts are supposed to be public. That's the principle. Contracts should be public, which means any potential clients can actually see them to actually see how to sign a contract. However, assertion in Java, for those of you who ever use it, if you haven't, you can take my word for that. If you simply do assert something, some condition, and then you generate a Java doc from that, assertion never appears in the API of the class, which means even though you have this particular class invariant to be checked, it never appears in the API, meaning that any potential clients, they cannot find out this invariance, which is not good. Contracts are supposed to be public. That's a principle. But assertions are not public in Java, even though it does the runtime check. Okay? That's disadvantage number 2. And everything is in the slides. I'm just saying that verbally in the context here. Okay, final thing is about the postcondition. I would say out of the 3, precondition might be the easiest one because it's just checking the inputs. That's easy. Class invariant in some way very important. You want to think about what are the global properties for every object for a particular class. Postcondition technically is the most challenging one to specify because you want to specify the relationship between the pre-state and the post-states. We'll definitely talk about it thoroughly, maybe on the second half of today and also on Wednesday. How about post-condition in this case? Okay, I'll use a different color. For the post-condition, basically we have to also use an assert. And then we simply, again, doing a Boolean condition over here. But now the problem is, as soon as after the updates of your method, the attribute value has been overwritten. So now it's always a current value. So you have to make sure you cache or you store the value temporarily. You have to do this manually yourself, which is not good. Every time anything you have to do manually, that means it's error prone. We are humans afterwards, right? It's difficult to automate it. Okay, so that one is a post condition. And again, consistent with what I just said, since for the post condition, you're also saying assert, which means this is not public. If it is not public, any potential clients cannot see what are the obligations for the supplier, which is not good. All the contracts are meant to be public. Okay? So guys, it's a very quick overview of the supplier side. Okay? Review it. I think this may not appear on the exam because we don't test you on Java, but I think it's really nice filling the gap of the knowledge why we're using Eiffel for this course. Okay? One more thing to say. Not only that, for the supplier, it seems to be quite complicated to encode all three kinds of contracts. For the clients, it's also pretty bad. Simply because, let's say for this example here, I have a client here. He's trying to call the constructor. Okay, that should be version 5. Okay, and also we're calling the constructor for version 5. Also, we are calling the withdraw method. Because every method you're calling, potentially they might throw some precondition error conditions, right? In that case, you are forced as a client to do try and catch. You can see for me as a client, all I want to do is call things like this, only this block. This is all the clients want to do. Wants to do. However, the overhead is quite substantial. You can see the try here and all the catch block over here. So these are all the overhead for the clients to write. You can see it's inconvenient not only just on the supplier side, but also on the client side. So that's why we said doing design by contract in Java may not be so ideal. So we want to really train you with a proper level. So that's why we chose another language. Okay? Every contract we talk about here can be done natively, which means much more easily in Eiffel. But we're going to review the syntax quickly together with you. Okay, that will be the last mention about the Java doing design by contract. Any questions for me? Just conceptually, are you okay with precondition, postcondition, class invariance? Yes?
Would a class invariant be written out multiple times within, say, a single method?
Single choice principle. Yeah, let me just mention that quickly. We'll definitely talk about single choice principle a lot in this course. So called single choice principle. Single choice. Single choice principle simply means you got redundancy in your design. If you got redundancy, that means if you want to change something amount of redundancy, you have to change in multiple places, like a find and replace, which is not very good. It will be very nice if there's only a single place you will change when you change your design. We'll see many examples throughout the course, don't worry. I just want to mention that's a first instance. Okay. Okay, so now let me just, okay, before I go to Eiffel, okay. So for you to finish off the study here, so everything I have mentioned, okay, I'm not skipping anything. So now why is better than version 4? We traced that already last time, okay? And then, so this is just a summary of what we have done from version 1 to version 5. And these are the disadvantages that I just talked about for doing design by contract in Java. It is doable, but it doesn't scale when things get complicated. Remember, we are only dealing with 2 requirements for the bank account, but it's getting quite sophisticated than necessary. Okay, so now this is just a table again for benefits and obligation. So whenever you proceed with design, always think about the table. You don't necessarily have to draw the table on the paper, but think about it. What should be the benefits? What should be the obligation? Okay, and then just to remind you. Okay, we got precondition here. So notice that the precondition should be the obligation for clients. At the same time, it should be the benefits for supplier. Okay, good. Okay, so now, okay, final summary. Okay, you can just go over that quickly. Everything has been covered. Okay. This is something we'll also revisit later. So now let's think back to 2030 or 2011. Every time when you are given a new library to use, because you don't have to reinvent the wheel, you can simply just use somebody else's library. However, that's kind of what you will get as documentation. So for example, you got an interface called list, and then the E over here is so-called generic parameter. We'll talk about it later in the course a lot, because every design pattern we use somehow has generics. And then the best you can get from a Java doc is about informal description for what the intended functionality is. But we're going to see if you do it in Eiffel, two disadvantages. Number one, you're going to write the contracts precisely. We're going to see that. Number two, every contract you write in Eiffel can be tested. They can be run and see in the debugger. Okay, still, these are the two advantages. Okay? I'll revisit this point a little bit later, but for now, you can just understand that all you can do in Java in terms of contracts is pretty informal, also inconvenience. Okay. But Java is a good implementation language, so don't get me wrong. It's just not appropriate for design. Okay, so now let me just talk about Eiffel very quickly, and then I need to cover how the contracts are precisely checked so you can have a very good understanding if you run into trouble in the lab. Okay, so now for Eiffel, okay, let me just go to this particular class over here. You can think about the account. So now we talk about Eiffel. Okay, the class over here called account, it basically corresponds to what you meant to do for Java account version number 5. Okay, so now you got syntax for declaring attributes, assuming that you have done lab 0. So this should not be too strange to you. I just want to highlight something for you. Okay, for every feature, in this case, we have a make, and that's the constructor. Okay, you got different parameters over here, and now this is the syntax you should know. Okay? One thing I want to mention, this might appear later in your lab. What's kind of the maximum syntax you can get for every feature? Okay? So think about, okay, features in Eiffel. One thing is you can have attributes. For attribute, you simply give a thing, let's say, for example, balance, and then you give a type, for example, integer. That one is very easy. Of course, it's a reverse order from Java. Okay. And then when you think about methods, in Java, you got either accessor or getters versus mutators or setters, right? In Eiffel, you can think about something similar. Okay, let's talk about first one. Let's call it about mutators, commands. It's basically similar to mutators. Okay, so now you have a given name. Let's say, for example, set balance. And names are separated by underscore, which is naming convention. And then you can get as many parameters as you like. And the way you declare parameter is similar to how you declare attributes. So you might say the new balance should be also integer, right? In Java, you would think you should put void. That might be how you're thinking. No, you don't need to put any type. Okay? That's not the case for Eiffel. If I see a feature like this, you got name, you got parameters, and you have no return type. That simply means a command. Okay? Now, what can you put for every feature, like a command or query? Right? We'll talk about query in just a moment. The maximum syntax you can get will be like this. Require will be the precondition. Okay, it's a keyword. And put some Boolean condition over here, followed by local variables if you wish. Local variable would be just the declaration. In Java methods, you can definitely just declare variables right before you try to use it. In Eiffel, no. You have to declare all the local variable in a single place. Okay, that's something you want to be aware of. You can declare local variables here, and then you have a do body here. Let me just make some space for myself. Okay, and then after the do, you can do whatever implementation you want. You can do an if conditional, you can do a loop, etc. After that, you will say ensure. After the ensure, I think maybe I should put it here. Okay, commands. And after the ensure, you're going to put some Boolean condition here for the postcondition, and then you have end. That's kind of the maximum syntax you can get as far as the labs are concerned. Okay? A very common mistake, very common, is to say you somehow put a local before the require. That doesn't make sense. Think about it in this way. You only get to the local variable, which is part of the implementation, when the implementation is actually satisfied. So that's why local appears after the require. Okay, good. Okay, think about just this guy here is the implementation. And the require together with the ensure, so these are the specification, the contracts. Okay, that's about the commands. Let's talk about query, which is very similar. The only difference is you have a return type for the query. So let me just use this. Okay, let's say queries, and then similar to accessor in Java for setters. So let's say we want to say get balance, for example. Okay, in the case where your query or command does not require any parameters, you might be quite used to putting things like this. No, it's a syntax error. When there is no parameter, you don't put anything. Just leave it. Just leave the name. Just like that. And then the get balance should return, let's say, integer. No parameters, right? And then after that, you can still get require, and then put something here. Local, you put something here. And then you put do something here. Ensure something here, and also end. Okay, that's the syntax. Similar, right? Okay, I will also pointed out some common mistake to you, so hopefully you can save you some time. Guys, any question about the rough syntax for features over here? Either attributes, either command, or query. So these are the three. Yes?
Before we can have any respect, we can say make or create, or
Okay. There might be a confusion over here. Let me mention that. The way we do constructors in Eiffel is different from Java. It's just a design choice for the language. Okay, I'll just tell you the rule. Commands, think in this way, commands versus constructor. The best way to think about it is constructor are simply just commands listed under the create clause. Okay, I'll illustrate to you. Okay, of course I'm going to just program on the iPad, but you should really try that out on Eiffel Studio. Okay, let me give you the simplest example. Let's say I have a class called A. Okay, just call it A, make it simple. And then I have a feature over here. I just call that commands. Let's make two commands over here. Make one and make two. And by the way, commands that are going to be used as constructed, they don't have to be called make. Just a convention they can be called make. Let's say make number one, something over here, use command, right? Do an end. Okay, let me have another one, make two. Do an end. So I'm running out of space, but you can imagine that end should appear at the end, right? Make one and make two. So now we got make one and make two. So these are the two commands we have. Okay? At the moment, we cannot create any instance of A if you try the following. So let's say this is the supplier. And then let's say we have another class that's called B. So B will be the clients. Okay? And then somewhere we have a local variable declaration for some feature. Let's say somewhere. Okay? We say local A of type A. Do. Okay? If I try to say creates A dot make one versus creates A dot make two. Let's say you also got some parameter here, right? Just make it a little bit more general. But here we also pass something. This is version 1. They are not going to compile. simply because there is no create clause declared for the class. Okay? Now, case number 2. I'm just going to copy this guy here just to show you different versions. Okay, version number 2. Let's say over here in the same supplier, I'm going to make a create clause. So I would say creates is a keyword. So now under the creates, I can list as many commands as I wish that are going to be used as a constructor. Let's say I want to make 2 to be a constructor. So I will say make 2. Okay, if I do that. So now a question for you. If I say this is 1, this is 2, can you tell me if both lines should compile or one of them should not compile or both of them shouldn't compile? Only are you sure one should compile? Are you sure? Okay. Creates is like a new in Java. Okay, it's like a new. Whenever you see creates in your code, that means you're trying to create a new object by calling constructor. However, this line here is not going to compile because make 1 does not appear in this list. As simple as that. You can only use a command as a constructor if that command is listed in the create clause. Okay? Now compile because make 1 not listed in the create clause. Following the same logic, should this code compile? It should, right? Because now you can see make 2 over here was declared over here, so this is fine. Okay, that's the difference. Let me just show you 2 more lines, just to clarify, just 2 more lines. So we know that line number 1 should not compile, and line number 2 should compile. What about this? If I try this, number 3, if I say a dot make 1, something. Number 4, a dot make 2. Just talk about compilation. Doesn't mean you have to run it. 3 and 4, should they compile? Both of them should, okay? Simply because you can see the feature over here. What you might have seen in lab 0 is after the feature is say you have some curly brackets and then you have none. So this is so-called export status. I'll talk a little bit more example later, but just for today. Export status simply means none of the client classes outside can get access to these. But now in this case, if you didn't put anything here, that's simply just public. Okay? So that simply means make 1 and make 2, they can be used as commands, normal commands. Okay. So number 3 and number 4, they're okay. And notice that no new objects are being created. No new objects. Whereas for number 2 over here, you have to create a new objects. The best way for you to really convince yourself, if you understand what I'm trying to say here, try to recreate this example here in a small project using Eiffel new. That would be the best way to understand. Otherwise, if you run into this trouble in labs or in lab test, the consequence might be more severe, right? You may want to try that before you have to run into that. Any questions?
So if we delete line 2, can we do line 4?
If you delete line 2, can you do? Okay, good question. Very good question. It's basically saying the following. Let me make it here. The answer is no. Okay. What you're asking was this. Let's say we have some local variable, and then we say a of type A. And then here we say do. Here we just say a dot make. Okay? I can call either one. Let's say I call a dot make 2. Okay? Make 2. It seems to be fine because make 2 is basically public. It's not exported to none. So make 2 should be able to be called, right? However, is it going to compile in Eiffel? The answer is no. Okay, actually, you know what? Thinking this way. If I run a similar code in Java, right? This will compile, not a problem. However, if I run at a runtime, what's going to happen? Null pointer exception, exactly, because A, being the context object for this method here, has not even been created. So there'll be null pointer exception. So the Eiffel compiler has something called void safety feature, okay? Void safety feature simply means it will do some checks systematically to make sure every time when you're trying to call a feature over here, the context objects must have been initialized to something. Otherwise, you got like a void, like a null pointer exception at runtime. Okay, so this would not compile. Okay, so this does not compile. And to find out more, look at Eiffel 101. The documents. You don't have to read the whole thing if you haven't, but at least go to the section for void safety. So that talks about it. Okay. If time permitted, we also try to give you more example later about void safety. Okay. It's a very common source of error. Let's say in the lab test, if you simply try to do something like this, and the compiler wouldn't be very happy. You want to know why. Okay. Okay. Any question about this? Are you trying to say, are you talking about the create clause over here?
Yeah, that was still there, but the feature was gone.
Okay. So the question was, let's say for my class A, alternatively, if I got creates, just have it there. And this simply just empty. So that means there's no constructor for this particular class. So you can never initialize it. It's syntactically available to you, but you may not want to do it because they'll make your class not very useful, right? Yeah. Yes?
My question is related to that. Is there a default constructor?
Oh, is there a default constructor? There is a default constructor there. It's called default creates. However, you know what? Let me talk about default constructor a little bit later. So otherwise it will take some time. Okay, yeah. But the answer is yes, we do have default constructor. And the way to do it is you just have to declare default creates. That's all you got to do. But I think for the labs, you don't really need them. Maybe for the project, you might need them later. Okay, I will talk about it maybe later if time permitted. Okay, any questions about this? Are you talking about line number 4? So line number 4 is actually okay, because you can see from line number 2, we're already using the create to create a new objects. So A is not void, not null anymore. So that is why in line number 4, you can actually call that. So that's not a problem. Yeah, exactly. So that's why you can use that as a constructor. Not really duplicated. So think it this way, okay? Think about over here. This part is where you define make2. And under the create, you're not duplicating the definition for make2. You're just saying, just list the names of the commands, saying that any external clients, they might use this particular feature or command as a constructor. You don't have to repeat the definition, just use the name. So it's not really duplication. Okay. Yes? Yeah, let me, you know what, if that's related to, So if that's related to lab 1, let me handle that maybe during the lab session. That might be easier. Okay, yeah. Yes?
Make2 is like, it's a constructor, but it can also be called as kind of like as a method.
Exactly. You can, okay, that's exactly right. So you can see over here, you are using make2 over here as a constructor. And over here, you're using make2 as a command. Yeah. Exactly. Exactly, yeah. So let me just write it down. That's exactly the right observation. You can think about the make2 over here is used as a constructor. Simply because you got creates. But over here for line number 4, this is used as a command. Which means no new objects being made, you're just modifying A directly. So you say it again, I don't quite catch.
If you initialize the object by using make2 as
Yeah.
a constructor,
Mhm.
are you allowed to redefine it using make1?
Oh, of course you can. Of course you can. What you're asking was this. Okay, let me just talk about it. That's no problem. So now let's say you got creates. Okay, don't forget we under the features, okay, we got the definition for make1, something here. And also we got a definition for make2 and something here, right? Okay. And now let's say under the create clause, I put make1 and make2, let's say. That means both of them can be used as a constructor. Okay? Let's now talk about the clients. Somewhere in the client, let's say local A of type A. Okay? And then if I say creates A dot make1, something, that's definitely fine. You were asking, can I say creates A dot make2? The answer is yes, you can do it. You're basically doing the following, okay? If diagram might help. When I do this particular line, I'm basically saying A is now going to point to an object of type A. And the way I initialize the contents for A is by using make1. Okay? And now, if I try to execute the next line, I'm basically saying I'm going to create just another object of the same type A, but I'm going to use make2 to initialize them. And then I'm going to assign A rather than to here, but now it's pointing to here. That's what's happening here. Okay. Right, any other questions? Yeah.
Just do the same thing as if you take out the create.
If I take out the create,
Mm-hmm.
sure. Okay. Let me just do the final illustration here. Well, this is important. That's okay, even though it's not really planned. Okay, let's say this. We have class B, the clients. And then let's say, again, somewhere we got a local declaration A of type A. Okay? And do. If I say creates A dot make2, for example. After this, I say A dot make1. Let's think about what's happening here. In total, only one object is going to be created, right? Because just one keyword. Just count the number of creates, like how you count the number of news in Java. What's happening here is this. When I first do this, I'm going to create A is now going to point to an object of type A. The way you initialize the field is by using make2. Okay, that's easy. So now, if you go to this line here, we are not creating any objects. We're basically modifying whatever A is pointing to, which is here. And then we're going to modify it using make1. Just modify it. That's what's happening here. No new object has been created. Yeah? For static, I would say let me talk about it a little bit later. We don't really need to use static in this too much in the example we're going to talk about. Okay, but you can ask me in the lab. That will be easier for me to address. Okay. Yes.
Can we delete the local variable A and then use the class A inside of do and delete the local variable but use class A inside the.
You're basically asking, okay, that's interesting. Okay, I see what you mean. You're asking, should I actually say creates brackets over here, and then I might say A here, and then A dot make2. You're basically asking this, right? Okay, the answer is it's not necessary. Okay, what do you mean? Okay, since you already mentioned. In Java, let's talk about syntax. You definitely got a one-to-one correspondence, okay? So now let's say this in Java. In Java, you say something like some objects is assigned to new. I'll put question mark over here. I put question mark simply means the question mark class may be the same as A or may not be. When it's not the same, that means you got inheritance. You may have some polymorphism over here, which we'll review later. Okay? So the question mark over here is simply just a class name, which may or may not be A, first of all. Okay? How do you translate this into Eiffel? Here's the syntax. Okay? In Eiffel, this is how you do it. Since you have a new, you will say creates. And then, before I do that, okay, let me just tell you exactly what you should do, okay? Let me undo it. First of all, we are declaring objects of static type A. The way to do it in Eiffel is to say under maybe local here, you're going to say obj is of type A. That's how they correspond to each other, okay? And then in the do and body over here, for the new, that means you have to say creates. And then whatever this type might be, you can put it, okay? Curly brackets, okay, for this one here, let me use a different color, let's say green. Curly brackets, and then put whatever the question mark is over here. And then finally, obj dot, whatever make feature you have, like that. Okay, that's the syntax. There is a syntactic sugar for you, okay? When the question mark over here is the same as the static type of the objects, you can omit. Okay, what do I mean by that? Okay, this one sounds maybe a bit slightly abstract. Okay, let me show it to you. Can we just say let's say we got class A, and then we got class B. So this is a child class, and this is a parent class. Okay, let's say. And then, so now I can definitely say the following. We have some local variable over here. Let's say A1, A, A2, also A. We got two A objects, right? Okay, and in the body of the implementation, we can say creates A1, assuming that we got make. Let's assume that. And also, we can say creates B A2 dot make. Both are okay. You can think about the A and B here are the dynamic type. We'll definitely review the static type versus dynamic type when we talk about inheritance, but I just want to talk about syntactic. So now this one here, you can see the dynamic type B is different from the static type A. So you have to keep this square brackets, the curly brackets. However, for this guy over here, you can see the dynamic type A is just the same as the static type A. You can write it slightly simply, more simply. You can just say creates A1.make. That's also fine when the dynamic type is the same. Try to experiment with this a little bit. If you really got trouble, ask me on Friday when we are in front of your computer. Or just drop by my office hour. I'll show you a little bit more to you. Okay, any more questions? Yes? Mhm.
we don't use another PA to modify the initial object, right?
Yes.
So does that mean modify the object type according to whatever make we use?
Okay. We don't want to overthink it, but basically thinking this, let's say this example here that we talk about. Basically, first of all, this line creates a new objects, okay, by using make2 to fill in the attribute values, for the objects. And this line here, we are just modifying this particular whatever object is being pointed to by A, and then modify that using make1. Okay, back in 2030, we talk about something called dynamic binding, meaning that if there are multiple versions for make1 in the inheritance hierarchy, which version of make1 you call depends on what the dynamic type is for A. If you're not too comfortable with it, that's okay. We're going to review this, okay, systematically. Okay, but I just want to mention that to you. Are we okay? All right. Okay, so that's about the Eiffel syntax. Okay, okay, that's something we just went over. Okay, and just notice that there's only a single place that we talk about invariance. Okay, let me highlight it quickly. Okay, it's very important for you to see that there's only a single place that we list the invariance. Remember, in Java, we have to do the assertion redundantly for every method, right? But in Eiffel, just a single place for the invariance. Okay, again, it's called single choice principle, but we'll do that a little bit later. Okay, one more thing to say. Every time when you do contracts, let's say for precondition here, for postcondition here, and for class invariant here, it's quite a common practice to actually do two parts for the contract. Okay, first of all, you can see this guy here, amount larger than 0, for example. This is a Boolean expression. So this is a contract itself. The second part you also have to understand is over here. So this is so-called a tag. Tag for this particular precondition, meaning that if somehow the client violates this particular precondition, in Eiffel Studio, you're going to see some stack trace for the contract violation. They will show you exactly non-negative amount as a tag. So it's actually just for tracing the bug, basically. Okay. I got a snapshot in the slides. I'll go over a few with you. But this tag here is for tracing the bug. Okay, tracing. And similarly for invariant, you can see there's another tag. And also you got postcondition, that's for another tag. Just give you a little bit preview for lab number 2. For lab number 2, you have to write contracts by yourself. And make sure every time you write your contracts, you also have a way to test it. We'll talk about testing for the contract a little bit later. Okay? Anyway, tags are very common. It's optional, but it's highly recommended. Okay, so now we talk about this, and let me see what's the next. Okay, it's just the syntax over here. Okay, so we already covered that. So I don't need to bother you with that. Just have a quick read. And of course, the best way for you to really understand the syntax is try examples. Try to go beyond what's really given to you for lab 0 and lab 1. You want to try example yourself. One more thing to say here. And then we're going to talk about how you can check contracts at the runtime. Okay. Okay, so now here. Let's say I have some commands, CMD, okay, just any command. You may have some parameters over here, and then do, and also end. This is the minimum you have to put for every command or query, the minimum. You might be wondering, I don't have any require or ensure over here. So at the runtime, what exactly will be the pre and post conditions? Okay? The answer is any unspecified pre or post condition or class invariant is equivalent to true, which means nothing. Which means anything that happened at the runtime will be considered as acceptable. That's not good, because not necessarily everything will be acceptable, right? You want to write just enough contracts. So this guy here is as if you do the following: command something here, require true. Do something here, and also ensure true. It's as if you do that. Having true for the precondition might be happening sometime because this you can handle just any input value. That might be okay. But I would say having true for the postcondition is not very desirable. Anybody know why? Let me lead you a little bit. If I have true as a postcondition, who should be very happy? Client or supplier? Supplier, because whatever they do, it would just be acceptable. Okay? Yeah, just conceptually you want to understand, and then it's easier for you to translate to the programming. Okay? This is not appropriate because no constraint on the supplier. Supplier. Okay. Okay, so let's go back here. Okay, I want to talk about this diagram here. It looks scary, but it's okay. Well, I'm going to show you exactly how contract is going to be checked, and then we're going to review the concept a little bit. It wouldn't take long, okay? Don't worry, I'm going to go over that. Okay, so what I want to do now is the following. If you bear with me just 10 seconds, I'm just going to prepare one thing on the iPad before I can start. Okay, we're just going to see some simple constructor and command calls, and then to see how we can interpret that. Okay, good. Let me just talk about the overall what we're going to do. Okay, I might be able to make it this bigger. Okay, big enough? Good. Okay. We want to see the following. We want to declare ACC of type account, which means we talk about using this particular class. And then we consider two method call or feature call. First of all, we call the make command as a constructor by passing some amount A, and also some name, for example. Okay? So the first one to call would be the make. And for the make, require will be the precondition. The only precondition we have is to say the balance should be, let's say larger than or equal to larger than 0. Okay. What about postcondition? There's no ensure. So what should we check? Well, isn't that what we just said 2 minutes ago? If there's no ensure, it's equivalent to true, right? So that means the fact that we don't have any ensure postcondition for the make, that means we simply check true at the runtime, which means anything that happened after the make will be acceptable. Okay, just to bear that in mind. And then after creating this particular account objects, we're going to call some feature on that. Let's say we call withdraw. So now for the withdraw, we're going to look at the contract view over here. The withdraw has the precondition, two preconditions, to make sure amount is larger than or equal to 0, and also amount is less than or equal to balance, right? Let's say that's something we discussed previously. And then, upon the termination for the withdraw, we want to make sure the supplier has done the right thing. So that's the postcondition. And we simply use the O keyword. I will talk about the O keyword a little bit later. But for as far as this example is concerned, think about the O keyword here. Is simply just going to refer to the pre-state value for the balance before it's being overwritten by the supplier. Okay, so you can compare the pre-state and the post-states. Okay, so these are the contracts that's involved. And also, don't forget, we also got class invariants over here, right? So these are all the contracts, let's say, you put down in your editor. But now we want to see exactly at the runtime how Eiffel runtime machine is going to check them. That's really important to understand them. Okay. Okay, having said this, let's try to see how that can be done, okay? To make it a little bit clean. Okay, let's do one by one, okay? Let's say we already declared this particular variable, okay? So now we are trying to call this particular constructor to make the new objects. Okay, when you look at the diagram here, we started with this line here. So we try to call this creates. So we are trying to create a new objects over here, right? So now this is starting state for your state machine. Okay. When we try to call this, the first thing to check, every time you want to try to call make a method call, we want to make sure the clients that calls this method has already established the precondition, right? That's something we said before. Okay. Specifically, what precondition should we check? We want to check to see if you look at the precondition for the make, the only precondition is the new balance over here should be strictly larger than 0, right? According to the definition. So that means in this diagram here, when we try to call that, the amount over here should be strictly larger than 0. That will be checked at runtime. Okay? If it is not satisfied, we're going to get precondition violation, and then everything terminates. Okay? And then if the precondition is really satisfied, that means A is indeed larger than 0, passed by the clients, we are just going to move on. And then, okay, you can see A larger than 0. So that means precondition is satisfied. And now we are ready to check the following. We are now ready to actually execute the body of the implementation for make. Let's say it's going to correctly set the balance into A. Okay, it's going to set a balance into A and set the name of the account owner to be N. It's going to do it. Okay, and then it's going to terminate. You can think about this is termination of the constructor. Once you terminate the method, you actually got two things to check. Okay, number one, you want to make sure since the clients already fulfilled their obligation, so that's why you can execute the body of the implementation. So now the burden is on the supplier's shoulder. You want to make sure the supplier actually fulfilled the postcondition, their obligation, right? So now the first thing to check is about the postcondition. And let's remind ourselves, what's the postcondition, by the way, for make? True, which means it's always satisfied in this case, just in this case. So that's why having a true for postcondition is not a very good design. Okay? You really want to put some meaningful postcondition, but we'll talk about it in a single lecture. Okay, okay, so now, okay, just in general, if somehow the postcondition is not satisfied, you're going to get postcondition violation and everything just stopped. Okay? You got to fix it before you can move on. Let's say if the postcondition in this case is satisfied, that means you go all the way to here. This is the stage where we actually already initialize the balance. For example, let's say this. Let's say for the make over here, I simply give you -10, for example. There will not be a postcondition violation because you can see if I give -10 over here, is there anything in the postcondition that will check -10 is illegal? Nothing. Okay, it will just pass the postcondition check. However, don't forget, we have the invariance over here to protect us. That's why after the termination for every feature, you have to check, first of all, postcondition, and then the class invariance. Think about the class invariance as a postcondition for every feature. Think about it that way. Okay, okay, so after this, we have to check to see, you want to think about this is the most important step. Okay, so balance over here is to checking the invariance to make sure integrity of the account is not compromised. Which means that you always satisfy that basic requirements for every account objects. Okay? Okay, question for you. In this case, do we satisfy the invariance? We don't, because remember I put a input value over here, -10, right? Intentionally. In that case, -10 will simply be set, the balance to be -10. So in that case, -10 larger than 0 is going to be false. So you're going to get the class invariant violation. That's one scenario. So you're going to stop over there. Okay? Okay, again, recap quickly. Before the method call, you check the precondition only. After the method call, you check the postcondition and then class invariance. Okay? And this kind of check has to be done for every method call. Okay, if the class invariant is satisfied in general, so this is the only state I filled in with green. So that means it's a safe states. Meaning that the invariance is maintained. Okay, guys, any question about this? Okay, let me just say one more thing. So what I have just discussed, in case you review later, what I have discussed so far is just about how to do contract checking for this particular line. We still got this line, but I'll make it quick. Okay, question?
Two questions. One is, if it's a negative number,
Yeah.
wouldn't the precondition catch it because A would be less than 0? So then if the precondition.
Yeah, yeah.
And another question is with the code, if we go back like a slide, there was a share, but there wasn't a do before the share. And before we would get like.
Okay, let me answer one by one. Okay, you're absolutely right for the first one. Sorry for the confusion. I was actually thinking about the case for withdrawal. Anyway, you're right. Okay. Let me say that precisely. Okay, if I really put minus 10 over here, okay, you're right. For minus 10 over here, it's now going to fail this particular precondition. We're going to get precondition violation right away. Yeah? However, if you try something like this, okay, I'll show you very quickly. Let's say for this particular one over here, let's say amount it should be larger than or equal to 0, and also amount is less than or equal to balance, right? If I simply, let's say if the current balance is actually 100, for example, and then if I pass exactly withdraw 100, in this case, you're going to get class invariant violation that we talked about it previously, right? Because the precondition will all be fine, but now, upon the termination for the method, you're going to see the balance will just be 0. So 0 larger than 0 will be false. So there's an invariant violation. Okay, another question. There's no do.
Yeah, there's no.
Okay, good. Let me just go back a little bit for you. Okay, so there are two possible views, at least two possible views you can have for your developments, okay? One is called implementation view. Basically, implementation view give you contracts and give you implementation, okay? You can think about as far as developers concerned, you definitely should really stay in the implementation view always. So you know the specs and also the implementation, okay? There is another thing called a contract view, okay? In lab number 0, one of the small exercises is to click on one of the icons of Eiffel Studio. And then, okay, let me just show you quickly. Oh, you know what? I always forget. Let me plug in the power. Otherwise, the recording will be gone. Okay. There we go. Okay, now we're safe. Okay, so now if you go to Eiffel Studio, I'll show you very quickly. Okay. You can think about normally when you do your coding for your class, I'll just give one of them. For example, I might be able to talk about this example today, but we'll see. Okay, anyway. Okay, you can see over here, we do have the do and body over here. Okay, and also you may also have require in short. One way to see the contract view is, you can see the view here, right? Currently, we are in the basic text view, which will show everything. And then you can also go to so-called contract view. In that case, it's going to hide all the implementation details. You can think about the contract view is more like the client's view. The client doesn't have to know anything about how you implement the stuff. They only want to know about contracts. Okay, yeah, that's why. Okay, let me go back here. And okay, back to the state diagram. There's one more thing I want to say. Okay, I don't have to trace it completely. I just want to highlight to you. Okay, so once we reach this particular so-called safe states, okay, so now that means we can now call any method we wish. So let's say now we want to call acc.withdraw. So we're going to follow the same pattern. Okay, let me just highlight it to you quickly. Basically, first of all, if you try to call this particular withdrawal method here, first of all, you have to check to see the precondition is satisfied. If it is, you can move on to execute the method. Upon the termination, you have to check to see whether or not the post condition for withdrawal is satisfied. If it is not, post condition violation, right? If it is satisfied for the post condition, you will simply just go all the way back to the same state over here where we were before. But now, should we check one more thing? Because we only check to see if the post condition is satisfied. We should also check to see if the invariance is satisfied again. If it is, we can now back to the original save state, and we can get more feature call. Okay? So this kind of process goes continuously until your application terminates overall. Okay? Every method call has the same pattern. Precondition first, upon termination, postcondition, and then invariance. Okay, any questions about this?
So the execute withdraw, that's actually the two blocks.
Yes, exactly. So yeah, so you can see I try to be very careful here. When I say call, it simply means we try to initiate the call. Nothing has been executed yet. We just check the precondition. So when I say execute over there, that means we are executing the body of the implementation. So that's execute. You're right. Yes. Guys, are we okay? Okay. Of course, you don't have to memorize this diagram. There's no point. But what I really want you to understand is what's being checked at the runtime. That's really important to grasp. Okay. Okay. So here I'll just mention one of them, the screenshots. Okay. You may have seen this already in Lab 0. Basically, what I want to highlight to you, let's say for the supplier, the account, I have this particular precondition with this particular tag. The tag is called positive balance. Okay? So now, in the client side, I'm trying to pass a negative initial balance. So that means new balance over here will be minus 10. So apparently, it's going to be false, so I'm going to have some precondition violation. And now, what you should really try to see is, in the Eiffel Studio, when they bring up the contract violation to you at the runtime, they're going to show exactly that tag name. And this corresponds to exactly this tag that you define in your class. So this is called traceable, right? You're tracing the error back to the code. So having a tag is very useful for debugging your design. Okay, okay. That's the everything else will be the same. You may have different precondition violation. You may have postcondition violation, etc. Okay, I don't need to waste your time. Okay. Okay. And this is just another, a little bit more general diagram here. I'm not going to go over that, but the one we just went over was specific to account creation and account withdrawal. This one just talk about, in general, you're creating an object for some particular class and how you can check contracts, between method call. Okay. This one is consistent. Okay. I don't need to bother you with that. I got about 10 minutes or so. I would like to do an example together with you, okay? And also maybe can introduce some syntax to you about Eiffel, okay? Let's talk about this exercise here. We're gonna practice to see how we can write contracts. And this is only for a particular command, so let's not worry about class invariant for the moment, just for pre and post condition, okay? Let me explain to you what this method informally intends to do. And then we're going to formulate the pre and post conditions as required and in short. That's a plan. Okay? Let's do as much as we can. Okay? I'll try to watch the time. Okay, change add is the name of the command. It has two parameters. Parameter number 1 is A of type array of string. Every element in the array A is a string. Okay? And then separated, okay, it's a semicolon here. Notice that. We have I integer. I is meant to be an index that's valid for array A. Okay? NS standing for new string. Okay? What it meant to do is something like this. I'll give you one example. Let's say I have my array that looks like this. Something here, and might be very large array, doesn't matter. Let's say this is index 5, for example. Okay? Let's say currently it is storing a string for Alan. Okay, let's say that's how I start with. That's A. And now, if I call this feature, I say change add. And then I'll simply pass A. And then let's say I want to change at index 5. And then I want to change that to maybe mark. What it wants to do is to change at index 5, the string into mark. Is it clear what it is supposed to do? Seems to be quite easy. However, it may not be as easy as you might think, but that's why we want to talk about it. That's informally how the method is going to do. Also, there's a comments for that. Okay? So now we want to talk about how we can formulate the obligation for clients as a precondition and the obligation for the supplier as a postcondition. That's what we want to do. Okay? Okay. Let's start with the precondition. Precondition usually is not that difficult to do. Okay? Okay, for precondition, anybody? Yes.
I guess never mind. I was going to say that the array has to have object string or type string, but I guess that's part of the...
Yeah, it's a part of the type checking, so you don't have to worry.
So
Yeah. I'll get to you. Okay.
I must be smaller than or equal to.
Okay, very good. It should be a valid index. There is something that's a little bit different from what you're used to. In Eiffel array, if we didn't specify explicitly, array indices start with 1, not 0. Okay? Let's just get used to it. Okay? Unless we tell you specifically in the lab test, you can assume array indices always start with 1. Okay? That means the indices should always be 1, 2, all the way to. For a array, you can say a.count. You can think about a.count is like a.length in Java. Okay? Okay, so now, do you want to tell me exactly what the precondition should be when I try to check this precondition for the valid index? So what I can do, number one, I can say valid index. Apparently, I want to make sure I over here is a valid index, right? Can you tell me exactly what to write? Okay, or I put it this way, I 1 less than or equal to I. And how do you say and? How do you say conjunction? And, okay, just in case, well, don't say this, okay? You're gonna get 0 for the lab test, okay? And. You might be wondering what's the difference between and then. I'll talk about it next time. Okay, I'll save it a little bit. Just say and for now. Okay, I'll just complete the rest for you. You can say I less than or equal to a.count. Okay, very good. I would say that's the main precondition we need. You might want to say, for example, maybe the size of the string, the new string should be non-empty. That's okay. I would say let's live with that. So now, our challenge now is for the postcondition. Here's my requirements from you, whatever suggestion you might have. Whatever you propose, I'll try to challenge you. Okay? Ensure will be the postcondition. I want your obligation that's posed upon the supplier to be as complete as possible, in the sense that the supplier has no scope to do something that's funny. You see what I mean? Okay. Anybody? We can start with something. What should be the postcondition for this method here? If you're really not sure about the syntax, just say it verbally. That's okay. Okay, we're still learning. Yes, you want to?
So, whatever index we change in string.
Sure. So now what about in this case? So you're suggesting something like a at whatever index we want to change into. In this case, would you agree that's I? Okay. And now we have to use tilde. Tilde is simply like an equals method in Java. Okay. Should be the same as new string. Okay, I agree with you. That's pretty good. Okay. Let me give a tag name for that, and then we'll discuss. Oops. Let me put it here. For the ensure, the first one is change at I. Okay, I can say AI now becomes NS. That one is not hard. Do you think this postcondition here can prevent any funny supplier from messing us around?
Should we ensure that the other
are not changed. Exactly. That's exactly right. So currently, I tell you what the problem is, first of all, and then let's see how we can formulate it. Okay? Let's say you're happy with this particular postcondition. Let's say that's it. Okay? What's going to happen is this. Let's say somehow the supplier, okay, is, when we make this method call or feature call, we want to change the index 5 into mark. Let's say the supplier does that. But at the same time, they also always modify, let me just use red to say it's actually something that's unintended. They always modify the last index over here to be, let's say, junk. My question is this. Let's say we leave our pre and post condition like this, the blue and the green. And the supplier somehow does funny thing like, not only that they will change position I, they will also modify the last index. Now, will the supplier be caught? No. Why not? Yeah, just check for it. It's as easy as that. Think about what's going to be checked upon the termination of the method. Upon the termination of the method, we only check this post condition only. Agree? That one there only check to see AI, in this case A5, has been modified to mark. Indeed, it is. So this one, check. However, nothing else to be checked, nothing else to be imposed upon the supplier. So that means the fact that they modified the last element to be junk is never checked. So conclusion is, the post condition here is correct, but not complete. Question? O keyword, I agree, but, okay, let's say this. But which element are you talking about? Apparently you want to make sure somehow if the index is not the one we intend to modify, then the old value and the new value should be the same. That's more or less what you're thinking. But let's think about how we can formulate it quickly. I got a few minutes. I would say let's do as much as we can. Okay? I would suggest this. It seems like we agree. Only having this post condition is not enough because we're disregarding the rest of the array except for index I. Can we do something to really address other elements in the array using something that you learned from 1090? Should I give you a little bit hints? Okay, I'll give you a little bit hints. Remember in 1090, you learned about this guy here? Should it be this or should it be that? Am I confusing you? This one? Oh, sorry. Should be this one? No, the other. Okay, very good. Okay, very good. Okay, so now for all will exist, right? Okay, make sure you at least review some examples. You don't have to review proofs, not just yet. At least understand the basic meaning for all and there exists. Okay? So now, very quickly, I just want to talk about scheduled solution a little bit with you, and then you can try it out before Wednesday. So when we talk about it, it will make more sense to you. So now, in this case, if we want to say, except for position I, basically from position 1 until position I minus 1, and then from position I plus 1 until the end, all these elements that are not supposed to be changed, we want to make sure each element, the old value and the new value are the same. Question for you. Should I use for all or should I use exists? Exists, I heard exists, I heard for all. I would suggest the following, okay? Why don't you try as an exercise? I think that's really important. I tell you what, I'm pretty sure you will see something like this, either in the lab test or even in an exam. That's why I really want to make sure you understand this pattern here. This happens all the time, okay? So now I would suggest before Wednesday, let me spend 1 minute and then we are done, okay? Before Wednesday, I want you to use either for all or exists, either one, okay? To formulate the following, okay? Or elements except the one at index I, which is the parameter here, have not changed. Their values between the pre and post states. Okay, do this just in the math. And then once we see the math, we'll see how easy it is to implement that in Eiffel. Okay, I'll see you on Wednesday.